much. Hi, hello everyone. So we're here to talk to you about fusion energy and AI, possibly some of the two most exciting topics you will hear, the AI for good. I'm Matteo Barbarino. I work for the International Atomic Energy Agency. We are the Center for Cooperation in the Nuclear Field, so we deal with everything nuclear. Also includes fusion energy, as you already heard. Fusion energy could be the energy of the future, holds lots of potential. It's a clean technology. It's very energetic process. Could be a baseload energy source. We're still in the R&D phase, so lots of research and development happening worldwide. And AI could be one of the solutions or technology that could help accelerate this R&D. And that's why we wanted to pitch to you what is happening in the fusion energy sector and the possible intersections with AI. So I'm here with Wang. Alan is a researcher at the MIT Plasma Science and Fusion Center. So my role here is to get you excited about fusion energy, and then Alan will tell you how to engage on fusion research and AI applications. So fusion energy is the energy that powers all stars, including our sun. It's the process that happens inside stars. So it's what get these balls of material to burn and produce energy inside a star, like in our sun. There's a lot of what we call plasma, so that's also the fourth state of matter. So if you add heat to a solid, what you get is it becomes liquid. If you add enough heat, it will become gas. And then if you add extreme amounts of heat, you get to a state which we call plasma. So when you reach the state of plasma, then fusion reactions will start to happen. So light elements will start fusing inside stars. And that's also because of the extreme gravity that keeps it all together. Now, as you can see from this photo, it's a process which is extremely non-linear. It's also hard to control. There are lots of solar flares that you can see from this photo coming out of the sun. So this is not to tell you that it's dangerous. If you have a fusion reaction inside a machine, it's not going to blow up the machine, but what it will do, it could damage your machine. And these machines are extremely costly. So it's a process that we wish to control extremely well and make highly efficient. And that's where AI can come to help. And Alan will show you some of the possible applications. And especially to make sure that we're not damaging this costly machine. So like I said, fusion takes place when light particles fuse together. So on Earth, the way we envision these fusion machines to work is by fusing two hydrogen isotopes, which we call deuterium and tritium. These are simply two different kinds of hydrogen that fuse together at temperatures that we can actually achieve sort of easily on Earth. So this is a process that we know how to replicate inside fusion machines here on Earth. And we do this constantly all the time. What we're still not able to do is to generate useful amounts of energy from this process. So we're not yet at a stage where we can produce enough energy to turn that energy into electricity. That's what we're working towards. There are several machines around the world and lots of efforts both in the public and private sector. But why is this sector getting really exciting? And that's where you can see a big analogy with what happened in AI. In the AI sector is there's being lots of investments now being made by private companies, philanthropists, and energy ventures in this sector. You will see over the last 3-4 years, over $6 billion have been invested in startups, private companies. Governments are now thinking about possible policies to move fusion forward, fusion energy. So we're seeing now a fusion energy governance being shaped up. And there's been lots of research breakthroughs also that you probably have heard of. Like these days, if you Google fusion energy, you'll see lots of news and different laboratories, and some of these private companies are achieving incredible results. And some of them are using AI, and they're partnering with some of the tech giants like Google, Microsoft, DeepMind, and even Sam Altman, the CEO of OpenAI, has invested personally in one of these private companies called Helion Energy. So there's lots of interest also in the tech sector in this possibly transformative energy solution over the next decades. So the interest in fusion is for the benefits the fusion holds, right? Fusion will not produce any CO2 emissions. It is safe. It can be controlled. There is no chain reaction in a fusion process. So we spend most of the time trying to keep it running rather than moderating the reaction. And Alan will show exactly how AI can help with keeping it running. It's reliable. It will be a base load energy, right? It's not something that will be depending on if the sun is shining or if the wind is blowing, but it's something that once you get it going, it's self-sustaining. It's sustainable, and then it's an efficient process as it only involves limited resources, and the fuel that you use in a fusion machine, it's very small. So, like I said, lots of breakthroughs. There's this sector is international. There are many efforts across the world. These are points that show you different fusion experiments around the world. And this photo it's a photo of the inside of one of these fusion machines, which we call tokamak, and it's basically a magnetic cage. It's a cage. It's a container with magnets around. And it needs to happen in a vacuum. So what you see here, it's a picture of the inside of the machine, and the fuel will be circulating inside there in vacuum, and it's contained by magnets. And the reason why we need magnets is because this fuel, it's charged. It's charged. So once it's charged, you can play around with magnets. You can actually control it, right? Because of the electromagnetic force. So I hand it over now to Alan, who will talk to you about how do we use AI to make this process more efficient.
Yeah, great. Thanks, Matteo. So like Matteo said, one of the things we like about fusion is that it's very inherently safe. Why is that? It's because the fusion reaction is actually trying to kill itself constantly. It's trying to die off. Actually, there's a computer that's constantly monitoring and trying to keep it alive. If you shut that computer off for 10 milliseconds, the reaction's gone. We call that event a plasma disruption. And plasma disruptions currently in today's experiments happen like daily. You can have them constantly. But you can imagine if you're trying to build a power plant and your reaction just goes away periodically, and it takes a while for you and a lot of energy to get going back again. That's really harmful for the economics. And another thing that sort of happens in the really high energy devices we build is you can start damaging the materials a bit. And that doesn't look too bad, and it's not too bad, but this is something that actually potentially causes a month or two of operations disruptions. And my group works on this problem of disruptions both from the physics perspective, from a machine learning perspective, from a practical engineering perspective. And we actually wrote a paper last year looking at the economics of this. And it definitely looks like we need to essentially make plasma disruptions go to a very low frequency for the economics to really work out for us. Here's a nice little picture of, for example, some of the numbers that matter about the plasma. Usually when you operate, it's sort of nice and stable, but then over time the plasma can start getting sort of unhappy with itself, and then it can eventually sort of terminate itself and sort of just fizzle out. And one of the big things my group spends a lot of time doing is applying techniques from both physics-based but also machine learning techniques to try to predict when these kinds of disruptions might happen. You can imagine you have a fusion experiment that's running, has lots of sensors, it sort of has eyes, and it's gathering data constantly as the machine's running. And then a machine learning model needs to take that data and quickly, maybe within a couple of milliseconds, make a decision about, do I think this plasma is going to disrupt? Do I think this plasma is going to terminate itself? If it's going to terminate itself, we should probably try to do something about it to keep it alive. So this is, a lot of people in my group work on things like this, and it's a very exciting and interesting area of research. Something else I personally work on and recently put a paper on is applying techniques like reinforcement learning to trying to make the plasma state more stable, more reliable, more operable. And there's been lots of really exciting works done on just directly applying reinforcement learning to control your reactor. And for the experiment we're trying to build that are more expensive, bigger, we've been exploring an alternative approach because there does need to be some element of interpretability and trust. And so what we've been working on is this question, like, can we use reinforcement learning and train sort of these AI policies to help us think about different physics scenarios? And then think about, these are different ways the plasma could try to terminate itself. In each case, how do we develop a strategy for keeping the plasma alive, keeping the fusion reaction going, and hopefully not causing everyone to have to spend a couple months trying to fix it. This sort of nice little GUI sort of vision here is we want the operator to be able to spin up a ton of different simulations in parallel under different physics conditions. And then the operator sort of says, hey, I want this out of my plasma. These are good things, these are regions to avoid. And then it sort of tells you, hey, this is how I'm going to try to do it. So sort of operational co-pilots, you can think of that. And part of the reason I'm here is, we have too many problems. Certainly for those of you who are from the machine learning AI world, we have a paper that should appear next week to appear in an ICML that should help you get started explaining some of the opportunities and problems we have in fusion that might be tackled with machine learning. Things like disruptions, but also things like physics simulations, designing better materials, and also trying to design experiments to get more information out of them. That's all I had. Thank you very much.
So if you're from the AI sector and you wish to get engaged with this exciting technology and to bring a new source of energy on Earth, please reach out to us and we're happy to work with you. Thank you.